Alright, so this video we are going to look at what we call out-load machine. Out-load machine is a system of two or more masses which are connected by the aid of an inextensible string over a frictionless pulley or a smooth pulley. I said, when you have masses connected by the aid of an inextensible string over a frictionless pulley or a smooth pulley, we term that system out-load machine. So let me just give you what now, a diagram, okay, to show an out-load machine. This is the frictionless pulley or a smooth pulley. Frictionless pulley or a smooth word now, a smooth pulley. Suppose we call this body M2 and we call this body M1. There will be a tension in the string. This tension in the string is like this. You have a tension in the string like this. The key thing under out-load machine is that when this body, okay, are released, they are set into motion. They will move with a common acceleration. I said, when this body that form what we call out-load machine, when they are released or they are set into motion, they will move with the same word, acceleration. So our job in this video is to get the acceleration of the system and equally the tension in the string. So let us go class. Let us go. So this body M1, we have its own weight acting downward. This body M2, we have its weight acting downward. So here I have weight of body M1. Let me call it W1. Then here I have weight of body M2, we call it what now? W2. Weight mathematically is the product of the mass of a body and the acceleration due to gravity. So we have weight is equal to what now? Mg. Weight equals to what now? Mg. Are you with me? But because this weight is for body M1, to differentiate the masses, you can say M1, W1 rather. W1 equals to what now? M1G. And for this, the weight of this body M2 will be equal to what now? M2G. Just to differentiate the masses. So I'm using M1G for W1. And I'm using M2G for W2. So class, suppose we assume that body M2 is greater than body M1. So this body M2 will be pulling body M1. So once this body is pulling this body will be accelerating what now? Downward. Okay? And this one will be accelerating what now? Upward. Are you with me? If this body M2 is pulling this one will be going downward like this, while this one will be going upward. So here, we have two forces acting on each of these bodies. We have tension in the string and we have weight of body M2, okay, acting on mass M2. Then on this body M1, we have tension in the string and weight of body M1 acting on this body M1. So let us have what we call a free body diagram for each of the what now? Masses. So for body M1, let us do what we call free body diagram. Free body diagram, okay class. So for body M1, we have this what? This diagram here for the M1. So let me bring it out. Okay, I have something like this. M1 is here. Weight of M1, W1 is equal to what now? M1 what? G. Acceleration is acting down upward. So we have A like this. and we have what now? Tension in the string. Now, whenever you have two forces, two or more forces acting on the body, we must get what we call the resultant what now? Force. Are you with me? Whenever we have two or more forces acting on the body, we must get the resultant what? Force. The resultant force is a single force that will produce the same effect as system of what now? Forces. For example, if I have this diagram, class, if I have this diagram, this body, it has force 10 Newton acting in this direction and force 5 Newton acting in the opposite what now? Direction. In as much as I have these two forces, I must get a resultant force, which will be a single force that will produce the same effect as this system of what now? Forces. This is 10. This is what now? 5. This 10 is more than this 5, which implies the body will act in this what now? Direction. The body will accelerate in this direction because this force here is more than the force here. 10 is more than 5. So what do we do in resultant force? The resultant force equals to the difference of the masses. When forces are acting in opposite direction on a body, the resultant force is equal to the difference in the forces. So we have 10 minus what? 5. And this will give us what now? 5. Equally, we have two forces acting on this body. Tension in the string and weight of the body, which is acting what now? Downward. The direction of the acceleration will determine which of these forces is higher in value. I repeat, the direction of the acceleration will determine which of these forces is more in value. Because this acceleration is going like this, it means this T is more than this. Tension in the string is more than the weight of the system. So here we have tension is greater than what now? W1. So how do we get the resultant force? It will be equal to tension minus W1 to give us the resultant force. The way we have it here. Okay, 10 minus 5 equals to the resultant force. So here we have tension minus W1 is equals to what now? The resultant what? Force. I'm using RF to denote resultant force. Okay? So let us go. So let me write this one off. Now, what is the resultant force? Force is equal to the product of the mass of the body and its acceleration. So here we have this RF, which is the resultant force, will change to what now? Mass times acceleration. So because this force is on body M1, I will call it M1A. You with me? So this place we have tension minus M1G equals M1A. M1G is the weight of body M1. Then resultant force is equals to M1A for body M1. So I'll call this equation what now? Equation 1. Then let us go to what now? Free body diagram of body M2. So for the M2, let me just isolate the diagram. I have this. For the M2, we have this system. For the M2. Okay? Then this is W2, which is equal to what now? M2G. This is tension in the string acting upon. These are what now? M1, M2. Where is the direction of the acceleration? It's acting downward. And I said the direction of the acceleration will tell us which of these forces is more in value. Because the acceleration is going downward, it implies that this W2 is more than the tension in the string. So for us to have resultant force to be W2 minus tension in the string. So here we have over the M2, we have W2 minus tension will give us the resultant force. What we're trying to do is just to get the what? Acceleration of the system and the tension in the string. We want to get the acceleration of the system and the tension in the string. Let us get the formula for the acceleration of the system. So this one becomes M2G plus T equals to what now? M2A. I'll call this equation what now? 2. Okay. So let me combine equation 1 and equation 2 and we solve it simultaneously. Okay? Combine equation 1 and equation 2 and let us solve it simultaneously. So let us combine. Combining. We have first one T minus M1G equals M1A. And we have M2G minus T equals to M2A. Okay? What we're trying to do here, you see questions in JAM under Arthur machine. You see questions in JUPEB under Arthur machine. You see questions for 100 level students under what now? Arthur machine. So this concept is a key concept under mechanics. Okay? This is one of the applications of Newton's third law of motion. One of the applications of Newton's third law of motion is what we call composite body. Meaning we have system of bodies, okay, which are connected by the aid of the word now in a extensible string. So that body is what we call an Archimedes machine. So from here, what do we have? T minus T, we cancel out. We have left what now? M2G minus M1G. So this one becomes M2G minus M1G equals to M2A plus M1A. What do I do here? Some question. T minus T, we cancel out. M2G minus M1G equals to M2A plus M1A. G is going to go side and factor G out. Now M2 minus M1 factor G out, I have G here equals to A is going to go side here. I can factor A out. When I factor A out, I'll have what now? A open bracket what now? M2 plus M1. We want to get the formula for the acceleration of the system. So what are we going to do here? We are going to divide through by M1 plus M2. So you can pause the video and write this part because I want to clean this part now. Just pause the video and write this down. Have you seen the class? Alright, so let's continue. So from here, what do we have? For the acceleration of the system, what do we have? So we now be having divide through by what now? M2 plus M1, both sides. We now be having what now? M2 minus M1 bracket G all over M2 plus M1 is equals to M2 plus M1, which we have here, bracket our what now? Our A, okay, all over M2 plus M1. We are dividing through by what now? M2 plus what now? Plus M1. So what happened? This will cancel out what now? This. So it means the acceleration of the system output machine is equals to M2 minus M1 all over M2 plus M1. Then we have our what here? Our G. This is the formula for the acceleration of this system that we call output machine. So we can say it is equal to the difference of the masses all over sum of the masses times acceleration due to gravity. If M2 is greater than M1, okay, if M2 is greater, this is what we assume here, that our M2 is greater than what now? M1. Okay, so the beta mass will be in front. Plus, what of if M1 is now greater than M2? If I have M1 greater than what now? M2. So what will happen to be A is equal to what now? M1, you see it, minus M2 all over M1 plus M2, then we get what now? G. If M1 is greater than M2, we have this. So this, the beta mass will be in front. This one is M2 is greater than M1. That's why we have it like this. But if M1 is greater than M2, we have it like this. So I say, difference of the masses all over sum of the masses times acceleration 0 to. So for atom machine, this is the formula for the what now? Acceleration. Okay? So that's the formula for the what? For the acceleration. So let us go to the tension in the string. Because we have to find what? Tension in the string and the mass of the what now? Or the system. So let us go for the tension in the string. So permit me to wipe this one off. You can pause the video, write the concept down, and let me go to tension in the string. I'm going to use equation, any of this equation. So let me use equation 1. Let me use equation 1 for the tension in the string. Formula in tension in the string of an Apple machine. Please, young students, don't joke with this thing. First students, don't joke with it. Year 1 students, don't joke with Apple machine. You see it, it will come out. It will come out. Okay? If you need any physical lecture, you can call any of these numbers displayed on this marker board. For physical lectures, you can call any of the numbers. And don't forget to subscribe to our YouTube channel. We are on a mission to hit 5K subscribers. So please, if you learn one or two things inside this video, make sure you share it, subscribe, turn on the notification bell so that whenever we release videos, you will be among the first to see amazing videos like this. Share it with your friend, comment in the comment section below. The more you like the video, the more YouTube, okay, would display this video to those interested in Apple Watch. So like, comment, subscribe, and share the video. Let us continue the class. So from here, what do we have our T? Make T zero formula. T will be equal to what now? M1A plus M1G. And I factor M1 out. I have M1, okay, open bracket what? A plus what now? Plus G. I want to have everything in form of what now? Mass. I want to see A here, okay? I want to have everything in form of mass. So what's our A? Our A is this one. I will remember. M2 minus M1G all over M2 plus M1. So this one will change to M1 is here. My A will now become M2 minus M1 G, okay, all over M2 plus M1. So we have it like this. We have it like this. So that's our A. Then plus G. Plus G. Don't let us forget this G. Plus G is here. A is this. A is M2 minus M1 again G all over M2, which is this one. Then plus this G. So I have G and G here. I can factor G out. Now we are having M1, okay, M2 minus M1 all over M2 plus M1. If I factor this G out, I will have plus 1 here. Then here, I will now have my G outside. Let me explain. Let me explain this please. G times M2 minus M1 all over M2 plus M1. We have this. Are you with me? Then G times 1, we have this. I've factored the G out. Are you with me? So from here, I'll find the LCM. M2, M1 will be outside here. What's the LCM? M2 plus M1. M2 plus M1 and M2 is M1. That will give us 1. Then 1 times this, I have M2 minus M1. Then plus this one, just say 1 over 1 over 1. So how many 1 can you see in M2 plus M1 to be M2 plus M1? Then times what? Times 1. Consider that being M2 plus M1. Okay, then bracket what now? G. M1 plus M1 plus M1 will cancel out. Plus M1 plus M1 will what now? Will cancel out. So now we'll be left with, let's continue class. So we'll be left with what? Alright. So we'll be left with what? M1. Let me put something here. M1, open bracket, M2 plus M2 all over M2 plus M1 and what now times G. Because plus M1 plus M1 strike themselves out. M2 and M2 will be left with M2 and M2. Now M1, open bracket, M2 plus M2 is what now? 2M2. Okay, all over M2 plus M1 and what now times G. So I will now use this one here to multiply this. It means our tension is string because of what now? 2M2 M1 all over M2 plus M1 then times what now? Times G. Which implies tension is equal to twice the product of the masses all over sum of the masses times acceleration due to gravity. Where the acceleration is equal to what now? Difference between the masses as M2 minus M1 all over sum of the masses all over M2 plus M1 in times G acceleration due to gravity. So let us solve some question. Alright. So let's solve the question. We have these 2 questions to be solved. Okay, so this is the first one. Let me finish that. The masses M1 and M2 are hanged on a single fixed pulley as shown in the diagram below. This is the diagram. Given that M2 is greater than M1, so it means M2 is pulling M1, and the tension in the string is T. Which of the following equation gives the acceleration A of the masses when we are released? This is Y question, GC to be precise. GC question. GC external Y. Are you with me? So GC question. So these are what now? These are the formulas given. Which of them is the acceleration? See the first one, second one, third one, and fourth one. Mind you, M2 is greater than M1. And what is the acceleration of the system? Difference of the masses all over sum of the masses times G. So the correct answer will be, because M2 is greater than M1, give it to me, to be M2 minus M1. But if M1 is greater than M2, to be M1 minus M2. Is it clear? Because M2 is greater than M1, we have it like this. Because they gave us in the question for emphasis, that's why they put M2 is greater than M1. But if it's M1 that is greater than M2, the answer will be this. So the correct answer is option 1, option A. That's the first question. See the second question here. We have a diagram like that. We now calculate what now? Acceleration of the system and tension in the string. A, calculate acceleration. Okay, and B, calculate what now? Tension in the string. So how do you solve it? Apply the formula. Since it's out of the machine, we apply the formula. Let us go for that. Let's go for that. So don't forget to subscribe. We need any physical class. Call any of these numbers on the board. Any of the numbers for physical class. Prepare students, year 1 student, JAMB student. Are you with me? Then YES students. All year 1 students in all the universities in Nigeria. You can call these numbers for both physical and online classes. If you need online classes, call in on this number. Physical class, calling this number. Okay, distance is not a barrier. Not a barrier. Are you with me? So let us go. So here, what's the solution? M2 minus M1 all over M2 plus M1. Then by what now? Okay, G. Our G is 10, is a constant. So what are M2? M2 is 3 minus what are M1? M1 is 2 all over 3 plus 2 times 10. This will now be 1 over 5 times 10. 5 here, 1, 5 here, 2. It means the acceleration of the system is equal to 2 meters per second square. Acceleration of the system is 2 meters per second square. What about the tension in the string? Tension is equal to the what now? Twice the product of the masses all over sum of the masses times acceleration due to gravity. So we have 2m2 m1 all over m2 plus m1 then and what now? Times g. Just substitute. That's all. That will be 2 times m2 is 3 times m1 is 2 all over 3 plus 2 times what now? Times 10. So we have 2 times m1, m2 which is 3, m1 is 2 all over 3 plus 2 times 10. So what do we have here? So we have what? 2 times 3 is 4. 4 times 3 is what? We have 12 all over 5 and what now? Times 10. 5 here 1, 5 here 2. 12 times 2 gives us 4 meters. So God bless you all. I know myself. See you in the next video. Bye bye.